What happens when an engineer misses a signal while running a train? Or if someone forgets to line a switch back to the main line after they've done some switching or some maintenance? Well, bad things. Wouldn't it be cool if there was a way to double check all that sort of stuff and make sure that that bad stuff doesn't happen? Well, thankfully there is. What's up, guys? This is Heiss, and welcome to Positive Train Control 101. I think most rail fans have probably seen the PTC could have prevented this memes that are just absolutely everywhere. But as an industry professional who worked with PTC directly for 3 years, I feel like it's important that we should clear up what it actually is and what it actually does. PTC, or Positive Train Control, is when you reward a train for its good behavior, not like when you rub its nose in the oily mess it made in the pit. That's negative train control. All kidding aside, the real definition for positive train control is a lot more big picture than you'd think. It's because of that big picture definition that it adds this air of mysticism about it. I've seen countless Facebook comments, forum posts, YouTube comments, you name it, saying things like PTC has to be able to control the throttle of the locomotive and shut it off. And that's just not actually even a part of the real definition. It is a byproduct of what happens, but we'll talk a little bit more about that in a bit. The FRA, or Federal Railroad Administration, the people who oversee and regulate all train things, basically, in 49 CFR Part 236.1005, define PTC as a system that will reliably and functionally prevent 4 things: train-to-train collisions, overspeed derailments, incursions into work zones, which basically means don't hit the people that are working on the track or their equipment, etc., and moving through a switch on the main line that is thrown the wrong direction. Those 4 things are the primary 4 things that PTC has to do according to the FRA, and not really much more. And the nuance of how it actually accomplishes those things gets into a ton more details, which we'll get into in just a little bit, but there's also a couple other smaller items that are kind of minor bullet points that may not apply at every railroad that are also required. The FRA says that PTC must either warn or enforce for the following things. A derailleur switch that provides access to the main line is not currently protecting it, so derails down, switches lined for the siding. If a highway rail at grade crossing has had a failure and there's been a mandatory directive issued about that crossing, an after arrival mandatory directive has been issued and the train or trains to be waited on has not yet passed the location of the receiving train, which is legalese for saying if you get to move past another choo-choo once it's gone into a passing siding, it's cleared you, now you get to go. But if it hasn't cleared yet, we need to make sure it doesn't go, which, yeah, legalese is always fun. A movable bridge is not in its proper locked position to allow travel for trains, and any other hazard detector that's been incorporated into the signaling system must also then be enforced by PTC. Common example of this, at least up in the Pacific Northwest where I worked on PTC, was slide fences. They would basically run an electrical circuit all along these cliff faces, and if there was a rock slide that broke the fence, it would set all the signals to red, and then PTC would enforce that, because rock slides happening on the coast to scenic subdivision, relatively common. Now that's the FRA definition, of course, of what PTC is, but the funny thing is that it's not one singular system. There's actually a couple different variants of PTC made by different manufacturers. The FRA definition is just kind of the global, this is what we want you to have, and then the specific systems are a little bit separate from that. Most railroads use the IETMS, or the Interoperable Electronic Train Management System, from Wabtec, and that was what my experience was in, and that's kind of what we're going to talk about. So that was a whole ton of government mumbo-jumbo, legalese, the whole 9 yards. Let's make it a little simpler. What is PTC actually supposed to do? Well, think of PTC like a bouncer at a bar. At the bar, they have rules, like don't show up drunk and don't do anything stupid. At the railroad, they have similar rules, like don't show up drunk and don't crash trains into other trains. Sometimes both happen. PTC is the enforcement for the existing signal systems that we already have. We already tell engineers a ton of things that inform how they run. Timetables, signals, wayside signs, the whole 9 yards. Why not guarantee that those things are followed as a backup? Crews work 12-hour shifts at a moment's notice. A couple hours, you gotta be there, and your shift could start any point of the day. You might be tired, you might not have gotten good sleep, you didn't know if you're gonna work day shift, night shift, whatever, and you might be starting away from your home. That adds a lot of toll and mental stress to somebody, and we already know humans aren't perfect. And machines aren't either, but having a backup's not a bad idea. PTC enforces what the existing signal systems tell you to do. There's a red signal, PTC will make sure you're stopped before it. There's a switch that's in improper position, well, PTC is going to stop you before you run through the switch and blow into a siding at high speed. And the FRA definition did say each mainline switch, and that's a lot of switches, particularly when you think of the whole country. So who's gotta have PTC anyways? Well, as you may guess, particularly with this channel, the answer is it depends, because of course. PTC was mandated after an incident called the Chatsworth incident that happened in 2008, where 25 people died after the engineer on a Metrolink commuter train was texting on his phone and ran through a red signal and ended up having a head-on collision with another train. The combined speed of the two trains was basically 80 miles an hour, and the National Transportation Safety Board, NTSB, reported that the engineer on the freight train applied the emergency brake just seconds before impact, and that the passenger engineer never did. And they also noted that based on the geometry of the railroad, the trains only would have seen each other for 4 seconds before impact. That was the combined speed, sight lines, the whole thing. And because of that, you can understand why the FRA picked what they did for who needs to have PTC. If you meet these characteristics, you have to have it equipped on your railroad and locomotives. And that's each Class 1 that provides or hosts commuter or intercity passenger rail service. There you go. Any main line where any quantity of material poisonous by inhalation, PIH, including anhydrous ammonia, is transported. Don't want to have hazmat causing problems. Any other main line track used for regularly provided intercity or commuter passenger service, with a few little exceptions. And anything else the government deems important, which is unsurprising. So the FRA can always say, no, you need it, if you don't meet those criteria. So that was a lot about why we have PTC, who has it, and kind of the broad strokes of what it does. But how does it actually work, and what is it? It's positive train control, which is kind of not terribly specific. What are all the bits and bobs that actually make PTC? Well, it's basically broken into 4 different segments: the back office, the wayside, the onboard, and communications segments. Back office is, think of dispatch on the railroad headquarters. It's where all your data is. It's where all the information about the geometry in the railroad exists, and where everything talks back to, and you can see the global network of things. The wayside segment is where everything's actually tied into the equipment on the track at the wayside. Usually you go to a signal bungalow where all the controls and relays and all of that for the existing signal system are. And if you want to learn some more about that, feel free and check out Signals 101. This is kind of a spiritual sequel to that video. It only took me 2 years to get there. Thank you for bearing with me. PTC can tie into that and read everything based on talking to the processors and logic controllers that actually run the signal system. And so you're equipping all that stuff, and then that way you know what the switches are doing and the signals are doing and all that sort of stuff. On board, you equip the locomotives with all of the various things that they need in order so that the system can function, which is basically a really fancy computer called the Train Management Computer, or TMC, that has a number of different processors built into it. And that's kind of the brain of PTC that really gets into the nitty-gritty. But you also need to add GPS antennas to know where the locomotive is. You also need to equip and tie into the speed sensors on the locomotive to help corroborate what the GPS says. There's lots of little details that go into the implementation on a locomotive that adds a fair amount of equipment. And lastly, communications kind of goes a little bit everywhere. Unsurprisingly, there's a number of redundant systems in positive train control as far as communications go. The locomotives have Wi-Fi, they have cell modems optionally, you have a bunch of 220 megahertz radios, and the communication can go in a lot of different ways. Locomotives use Wi-Fi to do bulk data download if you're at a yard, to update software and all that sort of stuff, load the track profiles from the back office. They use the cell modems as a backup just in case GPS or the radios have failed, and that way you can still communicate over wireless networks. They use the GPS antennas to know where they are and communicate their position, and then the 220 megahertz radio, which is basically the primary form of communication, whether they're communicating directly to the back office or to the wayside via wayside radios, then down a hard line back to the back office. There's a lot of wiring and fiber optic and all sorts of things that runs along a railroad to make sure that everything works right. So with the 4 segments, you basically have the back office that knows everything, the locomotive that is doing the calculations and figuring out what it needs to do, and it's getting information from the back office and from the wayside via the communications piece. But how does that all work? How does it stop the train, or how does it slow down? What does any of that do? Well, basically, PTC ties into the braking systems on the locomotive, and it just depends on the type of brake systems that you have, how it does it. Older, totally pneumatic air systems like 26L or some of the even older stuff, they just tie into certain portions of the brake system with magnetically operated valves. If you end up having something where you need to slow the train down, PTC will put a penalty application on and reduce the brake pipe to penalty. Or if you really need to stop, say someone threw a switch in front of you or something somehow, and it goes into emergency service, it just dumps the brake pipe by opening the mag valve and not letting it close until the train has come to a stop. For more modern locomotives, it's a little bit more nuanced than that, because most modern locomotives these days have electronically controlled air brakes. It's actually pretty much the same as 26L that was designed in the 50s, but we've added computers and digital portions, and they do have a pneumatic backup in case the computers fail. But there is a computer that runs it, and PTC can directly talk to that rather than just having 2 valves that say, well, I can either reduce the brake pipe by a bunch or I can dump it. So you can be a little bit more smart and a little bit more nuanced if you've got better braking systems. And you'll note that this is where the piece about, it needs to shut off the throttle comes in. That's not something that PTC directly does or is required to do. Diesel locomotives have a safety feature built in called PCS, the pressure control switch. And if there's been a penalty application, an emergency application, something like that, that switch opens up and says, you can't load anymore, no more throttle. And so that's just a safety feature that we've had on locomotives so that you're not trying to pull through brakes and wear things out and accelerate when maybe you don't have enough train to hold you back. And so a lot of people in the steam railroading world go, oh my God, they're going to have to put a giant magnet butterfly valve in the throttle dry pipes. No, that's not something that's required for a steam locomotive because it's not technically a part of the system. And at the end of the day, most steam locomotives are probably not going to be able to pull through a dumped train, and anytime a steam locomotive is running over the main, there is so much extra visibility and extra folks making sure things that are working in the cab and being involved with all that, that the FRA deemed it like, oh, okay, it's okay that we don't have this because we've got a road foreman of engines and a pilot and all these people all paying attention to everything too. So how does the system really work on the locomotive? We know that it can control the brakes, but how do we get to that point? Well, based on the locomotive and the input from the engineer has to initialize PTC and say what the train is, input the consist information, how many tons, how many cars, all that stuff. Inputs that in, PTC knows how heavy the train is, and if you know how heavy the train is, and you know average braking capability with safety margins, you know how long it's going to take it to stop. Based on the GPS antennas and based on as well the speed sensors, axle alternators on the locomotive, PTC knows where it is. Even if you go into a tunnel, something like that, if they have enough data from the locomotive speed sensor corroborated with the GPS antennas, it can dead reckon its location, which sounds like something that would be a little strange. And we've already got the antennas, like, why do you need to do that? And it turns out certain locations, that was actually a very nuanced challenge. When we were trying to run trains out of Seattle, the urban canopy of everything and all the streets and the buildings, the GPS reception was really bad. And so PTC wouldn't initialize when we were at the platform. It ended up being that we would initialize at the maintenance terminal and run to the platform. And that gave enough good GPS data corroborated with the speed of the wheels so that it knew exactly where it was. And then when the GPS was lost, based on the good corroboration, it would say, okay, no, I know where I am because I know how fast we were going, and I can figure that out based on the subdivision information that I got from the back office. I know where we are on the subdivision, which is kind of a neat thing that they did to add an extra layer of safety and operational flexibility in places where it's hard to get that sort of reception. But based on the information from the wayside and what the back offices told the train about the different subdivision it's going to run on, the locomotive is always doing a curve of, okay, if I'm going this speed right now, how long is it going to take me to stop? What distance? And it'll come up on screen and shows up as a fence saying like, hey, this is where we're going to stop if there has to be a penalty or an emergency application. And should there be any target that pops up that causes that sort of thing, red signal, whatever, misaligned switch, PTC will say, hey, I'm going to give you a break. Like, I'm going to slow you down or stop you. And if you don't acknowledge it and you don't slow down the train yourself, it will take over it for you. So the computers on board within the TMC are always trying to figure that out. What's the distance that we need to stop on? We know the grade, we know the everything from the subdivision information that's all been GIS verified, all the positions, all these different things, and we've equipped all these different sensors on every signal, switch, bungalow, you name it. We now know, okay, this is the status of everything, and we can slow down or stop before we get to one of those points. And now let's talk a little bit about some of the PTC could have prevented that and some of the details that came about with trying to get PTC implemented. A lot of the jokes and a lot of the frustration and genuine frustration by train crews, you look at this as something that might be taking over your job, right? It's going to be able to do part of operating the train for you, braking and slowing down and, being that sort of thing. And then the nuance of getting this crazy of an interconnected system going. Anyone who's done any software or any ridiculous implementation bringing all these different systems together can tell you just how challenging and just how hard it can be and how many edge cases there can be. They're still updating things and learning more because certain situations are so infrequent that they haven't experienced some of them yet. So there's always little nuances and little changes that they have to update and do. And even then, as an engineer, when you run into some of those situations, the system is designed to be safety critical, safety first, conservative, right? You're used to being a commuter rail engineer and you've got places to be. You've got a tight schedule to keep on timetable. You're supposed to be blitzing up the railroad. As soon as you pull out the station, you got to be getting up to track speed. Well, maybe PTC sees your acceleration curve and realizes, oh, the rear of the train's not going to be totally clear by the time that you're getting a certain speed, and it stops you. That's frustrating because you've run that train that way forever, and you're not going to know perfectly, okay, oh, well, I was doing 21 across this crossover, and it was just the last car that was still on it. That doesn't make a darn bit of difference in terms of safety or ride quality, but the computer saw it and went, well, it was 21 and the limit was 20, so it put the brakes on for you. That's frustrating, and learning to run and deal with this system as well has changed some of those things. And that's where a lot of the opinion came from. It's because it didn't make a whole ton of sense for a lot of those situations right away. PTC took a long time to make and be required. 2008 was when it was mandated, and it was not until 2021 that things were actually required and mandated and you couldn't run without it. And actually, I'm saying 2021, but it might have been 2022 because they kept moving the target, literally, of you must have your trains equipped by this date or you don't get to run. And now at this point, if you're running on a railroad that has to have PTC, you don't have PTC. If you can't initialize, you don't get to run. If you have a failure en route, you basically get to run to a mechanical facility where it can get fixed, and that's the only option. The system's still not perfect, and there's still little details and new things to learn, but the reliability is actually approaching 99.9%, which is really good. But you think about the number of trains that run in the US, that means you still do occasionally have failures of the system and all that. And they're really trying to work on reliability and hitting that high target of true safety, because that's the whole point. This is a safety overlay, is what they like to call it. We're not thinking that PTC is going to run the train automatically and it's not going to be as smooth as an engineer. We're just thinking of it as being a backup to what an engineer does. If you missed the signal for whatever reason, you were tired, who knows? PTC's got your back. It's telling you everything that's going on right in front of you as well, and it's a great tech aid in that way too. And there's always the question of, well, this is kind of adding some automation. Is that going to continue? Or are we going to see unmanned trains? Well, there's lots of different opinions on that sort of thing in the industry, of course. But the people who regulate it, the FRA, just recently ruled that you have to have two-man crews on the trains. They don't even want to go down to one man, in the cab. So, well, it looks like the industry's committed, at least from a regulatory perspective, about having crews operate the way we always have. So hopefully that remains the case, because Lord knows if you have a technical failure or something, and we have automated trains, it's always nice to have somebody there in the cab that can make things happen. And beyond all that, there's still more future things to come. PTC got implemented, got mandated, it got added in, but some of it is not to the full functionality that everyone desires. And so they're actually talking about PTC 2.0 and coming up in the future here. And one of the biggest topics that was the buzz of the industry for that sort of thing was a little bit more on the grade crossing safety type things, and then as well for running into work zones. Right now, the way it's set up is the crews put in a Form B, and they get to go and occupy a section of track, and dispatch puts in the Form B manually. So, okay, we're working on the track from milepost 15 to 17. Cool. You tell dispatch gets the form, they put it in, back office then tells the train, milepost 15 to 17, you got a Form B, you have to stop, talk to the employee in charge, then maybe you can run through, that sort of thing. So there's no automation there yet. It's all based on people inputting things. So if you forgot to do your Form B, or if dispatch somehow had an issue putting it in or something, there's a chance that the train doesn't get to hear about it. And there have been incidents where, the switch was misaligned and the train came in and ran into a tamper and all that sort of stuff. And so they're talking about equipping the track-mounted vehicles for roadway work, all that sort of stuff, whether it's tampers, regulators, whatever, equipping them with some amount of PTC so that the trains can know where they are. And that just adds a ton more nuance and a ton more implementation. There's already a ton of work to equip all the locomotives you have, and now you got to do all the MOW equipment and that sort of thing. But that's some of what's coming up for PTC there. Hopefully this was educational. Hopefully you guys learned something. We didn't get into every single little detail because there's so much. It's such an interrelated, interoperable system that it really, really has way too much detail to go down the rabbit hole on. But this should serve as an overview of what it is, why it is, and kind of how it works, and gives you a little background at least. So let me know if you have any questions in the comments down below, of course, and as always, thank you so much for watching.